I have no idea what happened on Monday, unless I just had too many things stored in the Zoom cloud. But right after my last class, when I usually upload the homework, I had to run and do something. I can't even remember what, but I had to do something right away at 2 o'clock on Monday, and I didn't get home until closer to 5. And I looked and I was going to upload the notes, and Zoom said it was still processing the video. So I have no idea what took them so long to process those videos on Monday. But that was why they didn't get posted till later. And I could have sworn that I uploaded the Zoom link for every class, but somebody pointed out to me yesterday that it wasn't yet in your Blackboard. So I'm sorry for that. It was sort of ish beyond my control because Zoom was acting slow. Maybe it is me. Maybe I'm jinxing everybody. Maybe I have too much static in my hair. Today now, my labs isn't working for me. Do you see how I'm getting that service is not available? So I apologize that those notes weren't there as quickly as I had hoped they would be. But why do I have two versions of this open? I'm gonna actually give me a second because both of them are saying that something failed. And so I'm gonna just reopen that OneNote. Okay. So today we're going to look at expected value, homework 12, which was on the not or odds is due by the end of the day today. Homework 13, which is on the the independent events and the did I mean to say independent or did I mean to say mutually exclusive events? I think independent events and the conditional probability. I apologize. No, homework 12 is on the and the conditional probability. Homework 13 is on what we're looking at today, expected value. Did anybody want to look at anything from any of the homeworks before homework 13, homework 11, or homework 12? Did anybody have any homework questions?
No.
Okay, if there are no questions, then I'm going to go on the assumption that that homework 12 is all right. It's my understanding that with my labs, it's a technical problem and they're aware of it and working on fixing it. So hopefully it gets fixed before, if it's not fixed by noon today, what I'll do is I'll add 1 day to both of those assignments. Over here, this homework 13, which is expected value, which is what we're doing today, is the last new topic in chapter 11, the probability chapter. And so we're going to be tying up loose ends with probability. And so test 2 is on the horizon. I believe I uploaded into Blackboard for you folks the pencil and paper test that I used to give, although I think I'm going to go ahead and replace that with a review sheet that I have. It was a review for the pencil and paper test. I went through and I looked at the MyLabs test that I had created last semester, and it is very close to that pencil and paper test outside of question order. So we will go over that on Friday. And then on Monday, we'll see if there are any questions yet. And that test will be due, it'll be available from the end of class Monday till Wednesday. But if there are no questions on the review after we go over it Friday, Monday, we might start looking at that next section, which deals with statistics. So all of that having been said, let's go ahead and let's look at what expected value is. Expected value is something that we talk about when the outcome of an experiment is numeric. The outcome is a number or value. And the expected value is the average of the values of the outcomes over time. And so it might be something like I play the lottery regularly. If I pay $1 for that lottery ticket, you know, and the chances of winning each prize is given, what's the expected value of that $1 lottery ticket? Over time, how much money should I expect to win or lose? Or if I buy a raffle ticket and I pay $2 for the ticket and there's so many tickets sold and the prize is $1,000, what's the expected value for that average person who bought that ticket? Or we'll look at a couple other examples in a few minutes. In order to find the expected value, you don't have to, but my preferred way of finding expected value is to keep things organized and make a table. This table is going to have 3 or 4 columns, depending on what I'm looking at. In the first column, I'm going to just list all my possible outcomes. Every possibility, everything that could happen for my experiment. It's almost like listing the sample space. In that second column, I'm going to put the value of each outcome. Now, on occasion, the outcome is that numeric value. So sometimes these two are the same column. So sometimes these two are the only one column. But then that third column, I'm going to list the probability for each outcome. And then if you remember, we had said that the sum of the probabilities for all of the possible outcomes of an event is 1. So this column should add to 1. So the sum of this column is 1. I think when we look at the project for this chapter, where you'll be finding the expected value for a lottery game, where you're going to use numbers off of the state lottery website. And I think there's a little bit of rounding going on there. So that column doesn't add to exactly 1, but it adds to really close to 1. It should add to exactly 1 unless there is some rounding involved. And the last column is the product of the value times the probability. And so I multiply the two preceding columns. And what happens is the expected value is the sum of that last column. It's kind of like taking a weighted average. We're looking at taking the average of the values, but they're not all equally occurring, and that's where the probability comes in. I'm guessing right now that this list, this to-do list for expected value is about as clear as mud. So the rest of today, we're going to just look at examples. Do you guys need for me to wait a minute for you to finish getting this down before I start looking at examples?
Yeah, just a second, please.
Okay. And also with this is one of those things where you really want to have your calculator handy. And so even if you're done writing, to take a minute and go pull out your calculator, please. I guess you could do it without a calculator, but some of the multiplication gets a little dicey. And so I'm guessing that most folks don't want to multiply by hand.
I'm fine now. Thank you.
Okay. All right. So I have to apologize. I got distracted. Now I get next blank page. I'm going to skip over. I'm going to look at these expected value examples. If you want to just pay attention, I think I told you guys that all of the handouts for this chapter are in Blackboard in that handout folder. That's where that practice test will be. So if you don't feel like copying all of this down in a scurry, you can just pay attention and fill it in later or download them later. So over here, we're told that an automobile insurance company has determined the probabilities for various claim amounts for drivers aged 16 through 21, and they're shown in the table. We want to calculate the expected value and describe what this means in practical terms. So, first column are the amounts of the claim. And so do you notice over here, this column is my outcomes, but it's also the values. So this is one of those ones where the outcomes and the values are the same. The insurance company has gone through and looked at all of the claims that people made and found the probability of getting each claim. So what is this? 0.7, 70% of the time, people don't make any claims. Over here, 0.01, 1% of the time, people make a claim for $10,000. So that company has to pay out $10,000 for 1% of the people in that age group that they insure. So everybody all right, wrapping their minds around this table. I'm sometimes a little bit OCD. So I'm going to add at the bottom a column total. There's no need to total the outcomes, but I always want to find the total of the probability, because the total of the probability tells me if I've actually included everything. And so is there anybody with a calculator handy that can add this column for me and tell me what you get? Did anybody else get that that column adds to 1?
Yeah.
And that's what it's supposed to be. So we're doing well. Now the next column I'm going to create. In this next column, for lack of originality, I call the product. And again, because I think like a little kid, I like to say that the amount times the probability is equal to the product. Or I like to just make a little bit of a notation telling me that now to fill in this column, I'm going to just multiply across. I'll do the tough one. 0 times 0.7. Well, 0 times anything is 0. Next one, if I take 2,000 times 0.15, when you do that product, what are you getting?
300.
Beautiful. Then 4,000 times 0.08. Anybody else getting 320?
Yeah.
Yep.
6,000 times 0.05. What are you getting?
300.
Beautiful. 8,000 times 0.01. What are you getting?
80.
Beautiful. And lastly, 10,000 times 0.01.
100.
100. So is filling in that column all right? We're just multiplying across.
Yeah.
And so now here, the important part is this total, because this total of this column is going to actually be my expected value. And so when I add all of those, somebody check my addition. Are you getting 1,100?
Yes.
Yeah.
So the expected value is 1,000, whoops, 100. And so what does that mean? It means that the average claim of all the possible claims from all of the people is $1,100. It's not just the average of these numbers because they don't all occur with the same frequency. The chances of not making a claim at all is much higher than the chances of making a $10,000 claim. And so it's like a weighted average. Does that part make sense?
Yeah.
Okay, and so now we're thinking, okay, we own this insurance company. How much money should the company charge for its average premium if it doesn't want to lose money or gain money, if they just want to break even?
$1,100.
Yep, that would be that 1,100, right? If their average payout is 1,100, then they'd want to charge 1,100. Does this one make sense?
Yeah.
Okay, I've got a whole bunch of examples here. I don't think we'll have time to get through all of them, but let's look at this next one, example 4. And again, I pulled these out of the virtual textbook. So if you're wondering where they came from. Example 4, expectation in a business decision. You are a realtor considering listing a house for $500,000. So that's a $500,000 home. I guess $500,000 right now isn't that much for a house, but I've been using this example for the past 14 years. And 14 years ago, there weren't that many $500,000 houses around. The cost of advertising and providing food for the other realtors during open showings is anticipated to cost you $5,000. So you're expecting, as a realtor, to spend $5,000 if you get this listing. The house is quite unusual. You're given a 4-month listing. If the house is unsold after 4 months, you lose the listing and you don't make any money. You anticipate the probability that you sell the house is 0.3, 30%. The probability another agent sells the house, somebody else besides you, is 0.2. And the probability that the house is unsold is 0.5 or 50%, half a chance. If you sell the house, you make a $30,000 commission. If somebody else sells the house, you only make a $15,000 commission. Bottom line, you're not going to take the listing unless you anticipate earning at least $6,000. What? Earning $6,000? No, I want the $30,000 or the $15,000. Well, we've got to find what the average commission would be for listings of this type, what our expected values are. And so I'm going to make a table. Here, I'm going to list what could happen, the outcomes. For each outcome, I'm going to figure out what the value is for me. Then I'm going to fill in its probability. Then, whoops, I got to make my table a little bit bigger. I'm going to find that product. And again, for that product, I'm taking the value times the probability. And then in the end, these last two columns, I want a total. And one will make sure I'm including all the possible probabilities, and the other will give me my expected value. So with this listing, what could happen? The house could not sell. We could sell it, or somebody else could sell it. With me so far?
Yes.
Yeah.
Now, if it does not sell, I don't make any money. But because I listed it, and I had to have all those open houses and put out all of the cheese and crackers for the realtors and run all the ads in the paper, even though I didn't make any money, I had to pay that $5,000, right? Spend that $5,000. So wouldn't the value be that I'm out $5,000? And so in the same way, if I sell it, I make $30,000, but I had to pay that $5,000, spend that $5,000. So isn't the net value for me only that $25,000? And likewise, if I have to share that commission because somebody else sold the home, I still had to spend that $5,000 to advertise and put out refreshments during open houses and the like. So wouldn't the value for me just be $10,000? And so in here, we have to remember that the value is actually how much you make. Not made, M-I-D, made, M-A-D-E, minus the cost to you, what you paid. And does that need to subtract for that value make sense to everybody?
Yeah.
Now, if it's unsold, the probability is 0.5. For me to sell it, the probability is 0.3. And for somebody else to sell it, the probability is 0.2. They gave us those probabilities, so I'm going to go on the assumption that they figured them right. But just to be sure, if I add this column, does everybody see that it adds to 1? So I am indeed considering everything.
How do we get the 0.5, the 0.3, and the 0.2 on the probability?
In this problem, they told us. Over here, they told us the probability if you sell
okay.
3, somebody else's. So in this problem, it was given to us. Okay?
Okay.
Thank you for asking. So now if I multiply across negative 5,000 times 0.5, remember your rules for signs or use that negative button on your calculator. That gives me negative 2,500. And it's important to remember that that's negative, that I'm losing money there. Then if I take 0.3 times 25,000, I believe that gives me 7,500. Can somebody check me on that? And when I take that 0.2 times 10,000, well, when you guys multiply that, what are you getting?
$600.
0.2 times 10,000.
I
That
got
it?
2,000.
Were you able to get 2,000 the second time?
Yeah, I did it right.
Okay. And so now when I add those, and remember that first one's negative. When I add those, what do you get? Is anybody else getting $7,000?
Yeah,
And so that's my expected value. And so what that means is if all my life, all I did was list houses like this, half the time, I'm not going to sell it and I'll lose money. 30% of the time, I'll make the big bucks. 20% of the time, I'll make some money. So on average, for every listing like this, I'd expect to make $7,000. Does that make sense, folks?
Yeah.
yeah.
Great. Then I'm going to skip the, well, what time is it? Oh yeah, we got, I'm going to skip this one for a minute. I'm going to skip this one for a minute. I'm going to do this one. A charity is holding a raffle and it sells 1,000 raffle tickets for $2 each. One of the tickets will be selected to win the grand prize of $1,000. 2 other tickets will be selected to win consolation prizes of $50. Fill in the missing column in the table, then find the expected value if you buy 1 raffle ticket. So I want to stop for a minute. And before we fill in the missing column, I want to look over here at this probability column. Because in this example, Mr. Blitzer in his book was very kind and figured those probabilities for you. I want to make sure that if that column were empty, everybody would understand how to fill it in. So the probability of winning the grand prize, well, there's 1,000 tickets and there's 1 winner. So does it make sense that the probability of winning the grand prize is 1 out of those 1,000?
Yeah.
Yeah.
Now, there are 2 consolation prize winners. So does it make sense that 2 of those 1,000 tickets get second place?
Yeah.
Yeah.
So now if I put those together, does everybody see that there are 3 winners?
Mm-hmm.
But there's 1,000 players. And so does it make sense that there are 997 people who do not win?
Yeah.
And so that's where that 997 over 1,000 comes from. And from that line of reasoning, does it make sense that that's going to add up to 1,000 over 1,000, which is my 1? Now, when I fill these tables in, I have a tendency to think about that people who don't win first. If you don't win, the value is not 0. Isn't the value -2 if you don't win because you had to pay $2? And so I lose $2 if I don't win. Or I guess because it's a charity, we could say we make a charitable donation of $2 if we don't win. So if the consolation prize is $50, we're winning $50, but we're paying out 2. So doesn't that mean that my gain is actually $48? And in the same way, the grand prize is $1,000, but I had to pay $2 up front. So the gain is $998. Is everybody with me on those?
Yeah.
Yeah.
So we're going to take those values, multiply them by the probability, and that's going to give me the product. Here, because we're talking about money, when I do this multiplication, I think I'm going to change it into a decimal. So when I take 998 and multiply it by 1/1000, I get 0.998. If I take 48 and multiply it by 2/1000, I get 0.096. And if I take -2 and multiply it by 997/1000, I get -1.994. And now if I add that negative number to the positive 0.998 and the positive 0.096, I get a total of 0.09. Which, if I'm thinking about money, that's 90 cents. I'm sorry, that's negative 0.09. That's negative 90 cents. I apologize. And so when you buy that raffle ticket, you expect to lose 90 cents for each ticket you buy. So if I buy 5 tickets, I expect to be out $4.50. Does that make sense?
Yeah.
Now, this is from the perspective of you buying a ticket. Let's say instead you're in charge of the charity. If you were in charge of the charity, wouldn't you be making $2? Wouldn't this be positive? And here, wouldn't these be money that you're losing, that you're paying out? So we can say that person buying a ticket loses 90 cents each ticket that they sell. But couldn't we also put a positive spin on it and say that the charity earns 90 cents out of every ticket that they sell? So, yeah, sort of interesting. Let's see, 1, 2.
Why
Let's-
is
Go ahead.
it not 5 times negative 90 or?
It is. That's a negative. I had said that I had said that you lose the money, and by describing it as a loss, I was implying that it was negative. Thank you for making sure. If you lose 90 cents, then you're saying it's a loss is implying that it's negative. You're right. Okay. This next one I think is cool. And has anybody ever noticed that whenever you buy anything anymore, they want to sell you a service contract? You know, I buy a small appliance at Target. I bought a microwave and they said, well, for an additional however many dollars, do you want to buy an extended warranty, they call it, right? And did you ever
Yeah.
wonder why they're so willing to sell you those extended warranties? Well, let's
They
look
never
at
break.
this. Yeah, because they rake in the money. This question I want to look at like I'm owning the business, not I'm the customer buying the warranty. So it says a service that repairs air conditioner sells maintenance agreements for $80 a year. The average cost of a repair is $350. So if I needed to get my air conditioner repaired, paying $80 for me seems like a hell of a lot better idea than paying $350. And if I have the broken air conditioner, it seems like a good deal. But it says only 1 in every 100 people have an air conditioner that requires repair. So let's find the service's expected profits per maintenance agreement. And so we want to say what could happen, what the value is to us, what the probability is that this occurs. And then we're going to take the value times the probability to get these products. And we're going to find then the total of that to find our expected value. Well, if I sold one of these agreements, either somebody does not need a repair, or they do need a repair. Well, if somebody bought that maintenance agreement for $80 and they don't need a repair, doesn't that mean that I made $80 on the deal? But if somebody needs a $350 repair and they only paid me that $80, doesn't that mean that I lose $270 on that deal? Wow, that's a lot of money to be out, isn't it? $270. Crap. So let's see. Wait a minute though. The probability that somebody needs a repair is 1 out of 100 or 0.01. That doesn't happen too often. If 1 in 100 people need a repair, how many people don't need a repair?
99 out of 100.
99 over 100, or as a decimal, that would be 0.99. So if I take my 80 and multiply it by 0.99, I get $79.20. And if I take my negative 270 and multiply it by 0.01, I get negative $2.70. And so when I add, I make $76.50 profit on every policy I sell. So out of the $80, they pocket $76.50, and only a small portion of it goes to actual repairs. Isn't that interesting?
So why did you do 350 minus 80 equals a negative 270?
Oh, 350 minus 80 is 270, but It's money that we're losing.
Oh, okay.
Okay, you're correct. I was mistaken. It is a positive 270, but it's because I'm losing money. This is what I lose. This is what I make. And so that would be the loss. Thank you for correcting me. So I think we've got time for one more example. Let's look at this one. The spinner on a wheel of fortune can land with equal chance on any one of 10 regions. 3 regions are red, 4 are blue, 2 are yellow, 1 is green. They win $4 if it stops on red, $2 if it stops on green, lose $2 if it stops on blue, and lose $3 if it stops on yellow. What is the expected value? So I'm going to be quiet and give you folks 4 minutes to figure this one out. We don't need to subtract here because we're not being charged to play the game. We either just win or lose. How'd everybody do? Did we all get the same results or no?
Yeah.
Yeah. And so if something at the expected value is 0, that's considered a fair game. It means that your chances of winning and losing are equal. So that, that's, you kind of just break even. And so that's part of how they just define something as a fair game if the expected value is 0. But this idea of making this table to find expected value, all right. You could do it without a table, but I think without a table, it just gets messy. I think that putting it all in a table to keep it organized really makes it easier for you folks to find that expected value. I'm whoever has to leave, I just looked and it's time. Alan came in late. I got you, Alan.